getting the long-awaited Tesla numbers now for Q3.
They told you Tesla was the future, that it was the only game in town. They were wrong. Today, we're witnessing a paradigm shift that's rocking the automotive world to its core. Don't get me wrong, Tesla cars are great, but we're looking at the silent and undeniable rise of Chinese EV sedans catching up to and dominating their American rivals in selected areas. This isn't about flashy infotainment screens or gimmicks. It's about the real engineering and manufacturing might that's changing the game. Here are 5 reasons how Chinese EV manufacturers have crushed US EV manufacturers. 1. Battery technology. The battery is the heart of any EV. While Tesla has been a pioneer, Chinese manufacturers are unleashing a barrage of innovation that's hard to ignore. It's not just about kilowatt hours and range anymore, folks. We're talking chemistry, structural integration, and thermal management that's pushing the boundaries. BYD's Blade battery, for instance, is a game changer. Its lithium iron phosphate chemistry isn't just about being cobalt-free, which is a major ethical and supply chain win. It's about safety. Their battery can withstand nail penetration tests that would turn other batteries into a fireworks display. Plus, its cell-to-pack CTP design enhances energy density by eliminating the traditional module structure, freeing up space and improving efficiency. BYD claims a volume utilization increase of over 50% compared to conventional battery packs. Then you've got CATL, whose CTP technology is raising eyebrows. Its recent launch of sodium-ion batteries signals a potential diversification away from lithium that could have massive implications for cost and resource availability down the line. While still in its early stages for automotive applications, the sheer scale and R&D investment behind CATL's efforts suggest a future where battery chemistry is far more diverse. And China is leading the charge. Let's not forget about battery swapping. NIO built a network of over 2,000 power swap stations in China, thus solving 3 core EV problems: charging time, battery degradation, because the batteries remain NIO's problem, and technology obsolescence as users can swap in a newer, more advanced battery pack years down the line. Tesla, while still innovating with its 4,680 cells, is facing stiff competition in terms of the sheer variety and rapid deployment of new battery technologies. Chinese companies benefit from a vertically integrated supply chain, from raw material extraction to battery production, giving them tighter control over costs and innovation cycles. It's not just about building batteries, it's about mastering the entire ecosystem. 2. Advanced suspension systems. In the realm of advanced suspension systems, Chinese EV makers are stepping up their game, delivering ride and handling characteristics that can go toe-to-toe with, and in some cases, surpass their American rivals. Today, we're seeing sophisticated multi-link setups, adaptive dampers, and even air suspension systems finding their way into Chinese EV sedans across various price points. NIO, for example, has been particularly aggressive in offering high-end features like air suspension on many of its models, which has the ability to dynamically adjust ride height and stiffness based on driving conditions and driver preferences. Geely's Zeekr brand showcases a clear focus on driving dynamics, leveraging the engineering prowess within the wider Geely group, which also owns Volvo and Lotus. The result is EV sedans that aren't just quick in a straight line, but can also carve up corners with surprising agility and composure. Tesla, while offering performance-oriented suspension on its higher-end models, doesn't always provide the same level of sophisticated adjustability in its more mainstream offerings. The focus has often been on a firmer, more direct feel, which can compromise ride comfort on less-than-perfect roads. Just check out the many YouTube videos comparing Chinese and Western EV cars on suspension tests. My goodness, the Chinese EVs dominated the arena. 3. Advanced manufacturing. This is where China holds a significant trump card. Advanced manufacturing prowess on a scale that's frankly mind-boggling. The sheer speed at which Chinese EV companies can bring new models to market is a massive advantage. We're not talking about glacial development cycles. We're talking about rapid iteration and deployment. This agility allows it to quickly incorporate the latest technologies and respond to evolving consumer demands in a way that legacy automakers, including Tesla, sometimes struggle to match. Furthermore, the level of automation and efficiency in many Chinese EV factories is truly impressive. Gigafactories aren't unique to Tesla anymore. China is peppered with state-of-the-art facilities, churning out EVs at an astonishing rate. This scale translates directly into lower production costs and the ability to offer more features for the money. Consider BYD again. It is a car company, a battery manufacturer, a semiconductor producer, and a whole lot more. This vertical integration extends to its manufacturing processes, giving it unparalleled control over the supply chain and production costs. It's like having all the pieces of the puzzle designed to fit perfectly together, leading to streamlined production and fewer bottlenecks. Tesla has undoubtedly revolutionized automotive manufacturing with its own gigafactories and innovative production techniques. However, the sheer volume and the established ecosystem of suppliers and manufacturers in China provide a formidable advantage. It allows Chinese EV makers to scale production rapidly and efficiently, a crucial factor in meeting the growing global demand for electric vehicles. 4. Multi-sensor fusion. Tesla has famously stood by a vision-based approach and relied solely on cameras and radar. However, a solely vision-based approach has its flaws, and many in the industry believe that LiDAR, amidst other sensors, is a crucial component for achieving true Level 3 and higher levels of autonomous driving. The future of autonomous driving hinges on the ability of vehicles to perceive their surroundings accurately and react intelligently, and LiDAR makes this possible. LiDAR creates a high-resolution 3D map of the environment, offering superior object detection in distance measurement, especially in challenging lighting and weather conditions. XPeng has been particularly aggressive in multiple sensors in their vehicles. Its XPilot 3.0 and subsequent iterations utilize a comprehensive sensor suite, including multiple high-definition cameras, millimeter-wave radar, ultrasonic sensors, and high-performance LiDAR units. This redundancy and the fusion of data from these diverse sensors provide a more robust and reliable perception system. The computational power backing these sensor suites is also noteworthy. Chinese EV makers are often partnering with leading chip manufacturers to develop high-performance computing platforms specifically designed for autonomous driving tasks. This enables sophisticated sensor fusion algorithms that can process vast amounts of data in real time, leading to more capable and safer driver assistance systems. 5. Cost. Finally, let's talk about the factor that often sways purchasing decisions more than any other: cost. And this is where Chinese EV sedans often hold a significant and undeniable advantage. It's the ultimate trump card. Due to a combination of factors, including lower labor costs, a well-established supply chain for EV components, and intense domestic competition, Chinese EV manufacturers can offer vehicles with comparable or even superior features at a significantly lower price point, and we have the data to prove it. In Australia, the BYD Seal costs $47,000, while the Tesla Model 3 costs $62,000. In Germany, the Seal costs 46,000 euros versus the Model 3 at 50,000 euros. But it's not just about a lower sticker price. The Seal often comes with standard features that would be expensive options on a Tesla, like a panoramic sunroof and advanced driver assistance systems. Another great example is the IMLS 6, which is an absolute beast. In China, it costs 220,000 Chinese yuan, while the Tesla Model Y costs 250,000 Chinese yuan. And we're not talking about a stripped-down econobox. The IML6 packs a punch with features like crab walk functionality and cutting-edge LiDAR sensors. This is where the value proposition becomes impossible to ignore. This is a market where intense competition and an efficient, vertically integrated supply chain allow Chinese EV makers to offer more bang for buck, making electric mobility accessible to a broader range of consumers. It's a brutal price war, and the consumer is winning. Established automakers are suffering. So what does all this mean for the future of the EV market? It means the game has fundamentally changed. The narrative of American ingenuity leading the charge, with everyone else playing catch-up, is a relic of the past. The truth is, while we've been arguing about panel gaps and delayed software updates, Chinese EV manufacturers have not only refined their technology, but have built a supply chain and a cost structure that gives them an almost insurmountable advantage. They are not just building cheaper cars, They are building better, more technologically advanced cars for less money. And as they set their sights on the rest of the world, including Europe, where they've already grabbed a significant market share, the question isn't whether they will dominate the global EV market. It's whether American car makers can survive the onslaught. The era of American EV dominance is over. We just haven't admitted it to ourselves yet.